So, welcome to another class with STEM with Peter. Welcome. And today it's a very interesting topic in mathematics. It's a hell of a topic. If you are not sound in this topic, you will have a lot of issues. You are going to have crisis because for for many students, they shy away from this topic. I'm telling you, they think it's a topic that if you are going for engineering, if you are going for advanced mathematics, that's when you need it. But well, you actually need the basics because when you get to higher level, you actually see that it's the basis for differential calculus, and you're going to meet them in higher form and higher duration. They come in levels, but this is of a basic level, and we are going to be dealing with differentiation and integration. I've never seen a year that this does not come out in JAM. It comes out every year. You can never escape it, especially if you're a JAM student. There's no escape from differentiation and integration. But today we'll be dealing with differentiation alone because differentiation in its own is very broad. There are a lot of questions on that before we move to integration. So differentiation. So I took my time. To come up with my own terms. I took my time to summarize. I took my time to just break it down, key points, and I tried to solve real jam questions. I'm going to tell you the years that you can find them. It's there. So I'm going to give you sort. So differentiation measures how a quantity changes. Differentiation measures how a quantity changes. It measures how a quantity changes. Differentiation measures how a quantity changes. It measures how a quantity changes. So it answers your question like, how fast is something moving? How quickly is something increasing? What is the slope of a curve at a point? So that is basically differentiation. So let's think of this. If y is equals to x raised to the power of 2. So what this is basically trying to tell you is, according to differentiation, is as x is changing, y also changes. As x is changing, y also changes. So differentiation is all about how the quantity is changing in respect and in terms of one another. That's basically what differentiation is talking about. Now, there are basic rules. That you need to understand when it comes to differentiation. The basic rule that you need to understand when it comes to differentiation. The most important one of them, number one rule, is the power rule. The most important one of them is the power rule. I'm just going to drop little examples so that we can solve real and authentic questions that has to do with JAM. Now, power rule. Now, you see, the power rule is just telling us that if y is equals to x raised to the power of n. Now you need to be very, very careful. While doing this. Now this is the most important rule, like I told you. The power rule is the most important. It's the rule that you need to keep at the back of your mind. There's no rule that you are going to execute in differentiation that will not make reference to the power rule. Now, if y is equals to x raised to the power of n, now you see the x now becomes, now this n, we are going to multiply this n by the coefficient of x here. You know, n is the power. Now this is the power. Don't forget that this is the power and this is the base. Now we are going to multiply this power by the coefficient here. The coefficient here is 1. So this becomes n and this becomes x. Now, and I'm also going to take away 1 from this n minus 1. Now, we are going to do real-time examples now. Now, let's take a look at this example. For power rule. Now, if y is equals to x raised to the power of 5. If y is equals to x raised to the power of 5. Now, the most important rule in the power rule is telling us that now this 5 is the power. Now this 5 We multiply this 5 by the coefficient of x here. So the multiplication of 5, sorry, yes. So the multiplication of 5 by the coefficient of x here, the coefficient of x here is 1 because there's nothing there. So if I'm going to basically do that, so this becomes 5 multiplied by 1, which gives me 5. So I'm going to have 5. My x still remains, but I'm going to take away 1 from the power. That's the rule. You must always take away 1 from the power. So this becomes 5 minus 1. So which is equals to 5x raised to power 4. 5x raised to the power of 4. 5x raised to the power of 4. So it's a very simple rule. It's a very simple rule. Bring down the power. Bring down the power. We bring down the power, and also we reduce the power. Reduce the power by 1. Reduce the power by 1. You bring down the power and you reduce the power by 1. And you reduce the power by 1. So now look at another scenario. What if we are giving something like this? What if we are giving something like this? Y is equals to x. Y is equals to x. And they want us to differentiate that. They want us to differentiate this. So they want us to know our dy dx. Now, what does this give me? Very easy. Now, the coefficient of my x here, which is my base number, is 1. And my power of x here is also 1. Don't forget that according to the law of indices, the law of indices states that x raised to power 1 is the same thing as x. So there's a 1 there that is invisible to the eye. I don't want to call it invisible because it's there. It's there, but it's just not visible. So now if I'm going to do this, this becomes 1 multiplied by 1 because there's a 1 here as well. So this gives me 1. And I'm going to have something like this. 1x raised to power 1 minus 1. And this is going to give me 1x raised to 1 minus 1 gives me 0. And any number raised to the power of 0 is equals to 1. So 1 multiplied by 1 is going to give us 1. So our dy dx for this is 1. Our dy dx for this is actually 1. Now, that's that on power rule. Don't forget that I said that power rule is the most important rule. Now, there's also a key rule behind power rule. There's also a key rule behind power rule. Now, if there is no x, I want you to note the key rule. I just tried my best to break it down. If there is no x, it cannot change. If there is no x, it cannot change. So dy dx is equals to 0. So when there's no x, it means our dy dx is equals to 0. So for instance, if I'm given a question like this, y is equals to 7, there's no x here automatically. So my dy dx will be equals to 0 because there is no x. So that is power rule. That is power rule. The derivative of a number is 0. The derivative of a number is 0. Let me just add that. The derivative of a number is 0. The derivative of a number is 0. So this is this on power rule. Now there are a lot of questions that comes with power rule, but I don't want us to go into that first. I want to drop all the rules so that we can go into real-time questions, real and authentic questions on that. Now, I want us to go to the constant multiplication rule. The constant multiplication rule. The constant multiplication rule. The constant multiplication rule. Now, this is also easy as well. Now, this is actually easy. The constant multiplication rule. Now, one needs to keep all these rules if you are truly going to be a master of differentiation. If you are truly going to be a master of differentiation, one needs to keep all these rules. Now, this is actually very easy. Now, when we have something like this, y is equals to k x raised to power n. What it simply means is that they want you to break this down. So I'm going to say k multiplied by x raised to power n, and I'm going to differentiate it. I'm going to now look at this example. Now look at this example. Y is equals to 4x. Y is equals to 4x raised to power 3. Now, very easy. What do they want me to do? This is it. I'm going to break this down. 4 multiplied by x raised to power 3. And I'm going to now differentiate. Now, this one does not have x, so I cannot differentiate it. It remains as 4. So 4 multiplied by, don't forget that my power rule, I told you that you are going to need power rule in every rule. You are going to always miss it there. So this one becomes 3 times 1, because there's a 1 here. This becomes 3x. 3 minus 1. Don't forget that I told you that immediately you bring the power down. Immediately you bring the power down here with whatever is there. Immediately you bring the power down with whatever is there. So you have to subtract the power as well. That's 3 minus 1. And that gives us 2. So I'm going to have, this gives me 4 times 3, that is 12. 12x raised to power 2. 12x raised to power 2. And you might do it directly if you don't want to go through this long method. Now, look at this. It will still give us the same thing. Now, look at this. I have 4x raised to power 3. Now, they want us to differentiate it. Now, the same power rule is what we are going to use. 3 multiplied by 4 gives you 12. So, that is 12x. Don't forget that I told you that the coefficient of the base number is what you are going to multiply with the power. The coefficient of the base number, which is 4. 4 is the coefficient of x here. You are going to multiply with the index. That is 3. That's the power, rather. You are going to multiply with the power. That is 3. And you are going to take away 1 from the power. So this gives us 3 minus 1. So that gives us 12x raised to the power of 2. It's still the same thing. 12x raised to the power of 2. Very easy. So that's that. Now let's just go to the let's go to addition and subtraction of it. Now, what if peradventure we're giving something like this? Differentiate y is equals to x raised to power 3 plus x raised to power 2 minus x. Now, this addition and subtraction as well. Addition and subtraction under differentiation. Now, how do we do this? Very easy. We just differentiate them one after the other. Now, the first one is this. Now, let's differentiate this one. This one gives me 3 multiplied by 1, that's 3. X. 3 minus 1 gives me 2. 2 plus, this one gives me 2. X. 2 minus 1, that's the 1. I don't need to put it. Minus, and this one gives me what? This one gives me 1. 1 multiplied by 1, that's 1. 1 minus 1 is 0. So this one gives me 1. So I'm having this. This is my final answer because I cannot expand this any further. This cannot be expanded any further. So this is my final answer. That's just that on addition and subtraction. Now, product rule. Product rule. Now we are getting to the interesting part. Product rule. Now, like I said, power rule will always come up, but I tried my best to do this in a simple format. Now, product rule says that if y is equals to uv, then dy dx is equals to u dv over dx plus v du over dx. Now, this is the rule, but I tried my best to coin it out so that it will not become a source of problem to students. And this is how I got my own. So I turned my own to be v prime and u prime. So in my own terms, this is how I do my own. I make it dy over dx is equals to uv prime plus vu prime. That's how I do my own. I'm just telling you my own trick and my own method. So in order for you not to make serious errors, I'm just telling you the cheat. Now, let's take a look at this question. Y, this is an example. Let's take a look at this question. Y is equals to x, open bracket, x raised to power 2. Now, don't forget that multiplication, bracket in mathematical term means multiplication. Bracket signifies multiplication. So I'm going to do this. Now, we have two things here. We have x and we have x raised to power 2. Now, they are different. One is outside, one is inside. Now, I'm going to take this one that is outside. Now, go back to the rule. The rule states that if y is equals to uv, so we're going to represent them with u and v. So look at it. This one, so my x is u, my v is x raised to power 2. My x is u and my v is, or I can say my u is x and my v is x raised to power 2. Now, if I want to do it, I will also do my u prime. My u prime, what I mean by u prime is the differentiation of this one. The differentiation of this one, and my v prime is the differentiation of this one. So my u prime, I just call it u prime, is the u. Now, the u will now be power rule. I said power rule. Yes, use power rule for this one. Now, this one now gives you 1. This one gives you 1. That's all you get. Whenever you see a simple trick is that whenever you see a single variable like this, the differentiation is always equals to 1. The differentiation is always equals to 1. Now, let's differentiate the other one. Differentiating the other one is very easy. 2 multiplied by 1, that's 2x. Because 2 minus 1, after I differentiated the power, that's 2 minus 1 gives me 1. I don't need to write the 1. So it's automatically equals to this. So I have all the values that I need. I have my u, I have my du, I have my v, I have my dv. Now, so let's now input it to the rule, like I dropped it here. Now, our u is 1. So 1, open bracket, our v prime is 2x, plus our v is x raised to power 2, and our u prime is 1. So doing all this gives us 2x plus x squared. 2x plus x squared. Sorry. I think I made an error. I've made an error somewhere. This should be u now. This should be u. Yes, this is x. Our u is x. This is the formula u v prime. So this should be x. So this is 2x squared. This is 2x squared. So 2x squared plus x squared gives us 3x raised to the power of 2. 3x raised to the power of 2. 3x raised to the power of 2. That is that on product rule. Now, let's move to quotient rule as well. Quotient rule. Now, let's move to quotient rule. Quotient rule, on the other hand, too, is just the same trick with product rule. As long as you can, as long as you can be wise. You see, you just need speed and practice. You need shortcuts to navigate some questions. Now, this is quotient rule. Quotient rule is telling you that if y is equals to u over v. Now, product rule is multiplication. Quotient rule is division. So they are different things. If y is equals to u over v, now the y dx, I'm also going to give you my trick like I used it there. The y dx is equals to v du dx minus u dv dx divided by v squared. So I'm giving it, so the way I actually do my own is v u prime minus u v prime divided by v squared. So that's actually my own easy way. So when I do this, it actually saves me a lot of problem and a lot of issues. Yes, it saves me a lot of problem, it saves me a lot of issue. Now, let's look at a particular question. If y is equals to x over x plus 1, if y is equals to over x plus 1, they want us to find the y dx. They want us to find the y dx. Very easy. Now, you already know that if y is equals to u over v, so I'm going to input this one to this one. So I know that my u is equals to x, and my v is equals to x plus 1, and my v is equals to x plus 1. So now I already have this value. So my u prime, which is my du. So it just means I want to differentiate the u. Now, so this gives me, I told you that any single variable that you have to differentiate is 1. So this is 1 already. Now, when you are given x, just x alone to differentiate, automatically is 1. So this one actually too. Don't forget that when you are differentiating, you cannot differentiate the one that does not have x. So therefore, this one is actually good as useless as well. So when we are left with x alone, this one still gives us 1 in the same logic and in the same manner. So now we can actually differentiate it. So now let's differentiate it. I have all my values. So this gives me vu prime. So my v is x plus 1, and my u prime is 1, minus my u is x, my v prime is 1, divided by my v squared is x plus 1 raised to the power of 2. X plus 1 raised to the power of 2. So here I'm left with x plus 1 minus x divided by x plus 1 raised to the power of 2. So this gives me x minus x. If I'm going to collect like term, this becomes x minus x plus 1 divided by x plus 1 raised to the power of 2. And this gives me 1 over x plus 1 raised to the power of 2. 1 over x plus 1 raised to the power of 2. I'm just using that as examples so that we can fully understand what the quotient rule is actually all about. The quotient rule and the power rule is all about. Now, what if we're given fractions and powers? What do we do in that case? Fraction and power. Now, fraction and power. Now, root and I said fraction and power. Root and fraction. What if we're given root and fraction? Let's say, for instance, we have root x is, now, they want us to do this. They want us to differentiate this. If we are given that y is equal to root x, we should differentiate. What do we do? Now, the first thing is to translate this one back to index form. And don't forget that in indices, this is the same thing as x raised to the power of 1 over 2. Don't forget that in indices, it's the same thing as that. So I'm going to simply differentiate it. So my dy dx will now be, don't forget I'm multiplying this one by the coefficient here, which is 1. 1 over 2 x, and this one gives me 1 over 2 minus 1. It gives me 1 over 2 minus 1. And 1 over 2 minus 1 is the same thing as minus 1 over 2, because 1 minus half is half. 1 minus half is half. So if I'm trying to take away 1 from half, that's 0.5, I'm going to get minus 0.5 or the negative 0.5. So if I'm differentiating it, this is what it's going to be. This is what my answer is going to be. Say for another example, we're given something like this. Y is equals to 1 over x. What do we do? Very simple. I translate this one. I translate it back to index form. This gives me x raised to the power minus 1. And I'm going to simply do it. It gives me minus 1 8x raised to power minus 2. Minus 1x raised to power minus 2. Or I can say minus x. Just for the sake of explanation, that's why I'm putting 1. Now, minus 1x raised to power minus 2. So what I did there was that I multiplied this power by my coefficient here. My coefficient here was 1. So I multiplied it by that. So, and I have to take away 1 from negative 1. So taking 1 away from negative 1, that is minus 1, because I already have a deficit of minus 1 already. So that's minus 1, minus 1, minus 1, because you must take away 1 from the power, and the power is minus 1. So taking away 1 from minus 1 gives us minus 2. So this under roots and fraction. Roots and fraction. So roots and fraction. Now, I want us to treat, let's look at real good examples. Good examples. JAMB, this is JAMB 2008. JAMB 2008. This is JAMB 2008. Now, find the derivatives